Okay, Year 9, this is lesson 4 for our topic of volume. In this lesson, we're going to look at the volume of circular solids. So far, we have learnt about the units of volume and capacity, the volume of a prism and the volume of a pyramid. This lesson is going to be concerned with cylinders, cones, and spheres. Now, whilst a cylinder is not technically a prism, we actually use the same formula. Do you remember the volume of a prism? It's the area of the base times the height. And with a cylinder, the area of the base is a circle, so it's pi r squared. So our formula is pi r squared h. Now it's just a matter of substituting into the formula. The radius is 4, the height is 8. Don't forget that there are multiplication signs in between pi and r and h. So it's pi times 4 squared times 8. We put that into the calculator, we get 402.1 centimeters cubed. We can also work out the volume of shapes that have a uniform circular cross-section, like this one. The base shape here is a semicircle, and it's the same all the way through. So we can work out the area of this base shape and then multiply by the height, we'll have the volume. So the base shape is a semicircle and has diameter 4 meters. So we've got an extra step we have to do. We have to work out the radius. Do you remember how to do that? The radius is half of the diameter, so it's 2. So the area of our base shape is a half times pi times 2 squared, which is 6.3 meters squared. And now all we have to do is multiply the area of the base by the height, and that gives us the volume. So it's 6.3 times 3, which is 18.9 meters cubed. So a cylinder is not technically a prism, and a cone is not technically a pyramid, but just like a prism, it has the same formula. So a volume of a cone here is 1/3 the volume of the corresponding cylinder that has the same measurements. So let's find the volume of this cone below. Here's our formula. See if that makes sense. 1/3, because it's like a pyramid. Pi r squared is the area of the base times the height. This time we do have the radius, it's 2.5 centimeters, and we have the height, it's 1.2. Let's substitute it in, and into the calculator gives us 7.9 centimeters cubed. And finally, sphere. And a sphere isn't like a prism or a pyramid, it's its own thing entirely. And here's its formula. It's 4/3 pi r cubed. Here's an example. Find the volume of a sphere with radius 3 centimeters. Can you see how we only need one measurement? Because that 3 centimeters is sort of like all of the different dimensions. So we're going to do 4/3 times pi times 3 cubed. And that gives us 113.1 centimeters cubed. Now, one thing I haven't covered in this series of videos is how to work backwards. We might be given the volume and asked to find one of the measurements, like the radius or the height. Here's an example. A sphere has a volume of 65 centimeters cubed. What is the radius? So here's our formula, 4/3 pi r cubed. But instead of putting something in for r, we're going to put the volume in as 65, like this. Now we have an equation that we can solve, and we've got to systematically get rid of the 4/3 and the pi and the cubed until we get r by itself. Start by getting rid of this 3. It's a divide by 3, so it's going to come over here as a times, like that. Now let's work that out. 65 times 3 is 195. Okay, now we're going to get rid of the 4 pi, and I'm going to divide both sides by 4 pi, like this. 4 pi divided by 4 pi, that cancels out. So I've got 195 divided by 4 pi is equal to r cubed. And that's roughly 15.52. The last thing I've got to do is get rid of this cube. Now, what's the opposite of cubed? It's the cube root. So I'm going to take this cubed, it's going to come over as its opposite as cube root, like this. I have switched those around, hope that's all right. And on your calculator, you can do the cube root of 15.52, which is 2.5 centimeters. Okay, as always, we're going to finish off with a couple of practical problems. The radius of the Earth is approximately 6,371 kilometers. What is the volume in cubic meters? So here's our formula, 4/3 pi r cubed, which gives us, in scientific notation, 1.08 times 10 to the power of 12 kilometers cubed. Now I've got a bit of a problem. Here we have kilometers cubed, we want cubic meters or meters cubed. So I need to turn each one of these kilometers cubed into meters cubed. So I'm going to times by 1,000 for each one of the dimensions because I'm going cubic measurement to cubic measurement. So I'm going to do that whole thing multiplied by 1,000 cubed. Now if you just put that into your calculator, you get 10 to the power of 21. So it's 1.08 times 10 to the power of 21 meters cubed. The mass of the Earth is 5.9 times 10 to the power of 24 kilograms. What is the average density of the Earth in kilograms per meters cubed? Now, if you haven't heard of density, it means how thick something is. But we're kind of given a formula here, kilograms divided by meters cubed. So kilograms, that's the mass, and meters cubed is the volume. So there's our formula. Let's substitute in. So there's 5.9 times 10 to the power of 24 is the mass. 1.08 times 10 to the power of 21 is the volume. Into the calculator, use your scientific notation button, and you will get 5,463 kilograms per meter cubed. So that means every cubic meter of the Earth, on average, weighs 5,463 kilograms. Okay, last question. A cylindrical water tank has a radius of 2 meters and a height of 1.2 meters. Find the volume in meters cubed and use the conversion 1 meter cubed is equal to 1 kiloliter to calculate the capacity of the tank. All right, let's start with the formula, volume of a cylinder. Pi r squared h. What have we got? We have the radius and we have the height. Great. So it's pi times 2 squared times 1.2, which is 15.1 meters cubed. And 1 meter cubed is the same as a kiloliter. So these units are interchangeable. So our volume is 15.1 kiloliters. The tank is full, but the water is seeping out at a rate of 12 liters per hour. How many days will it take for the tank to empty? So we've got a volume of 15.1 kiloliters, but we've got a bit of a problem because we have a mismatch of units. We've got kiloliters here and liters here. So let's turn this one into liters. There are 1,000 liters in a kiloliter, so let's multiply by 1,000. And it gives us 15,100 liters. Now we want to know how many 12s go into that amount. So we want to do 15,100 divided by 12, which is 1,258 hours. Okay, we want to know how many days it'll take to empty, how many hours in a day. There are 24, so we want to know how many lots of 24 go into 1258. So we're going to divide by 24, which gives us 52 days. Okay, that's it for this lesson. In our last lesson for this topic, we're going to look at volume of composite solids.